This is a talk from some work I've done with IMPALA Canada, formerly with North American Palladium, on mid-continent rift intrusion called the Sunday Lake intrusion, which is just north of Thunder Bay, and is largely a petrographic evaluation of the lithologies encountered in this very nicely differentiated layered intrusion, which shows several zones of mineralization. So I'd like to highlight that today. Oops. So again, I showed this map before. There's a variety of these small intrusions that we just heard about: Eagle, Tamarack, which is held by Talon Metals in Minnesota, the basal Duluth complex, of course, different breed of contact mineralization. Sunday Lake is up here, just again north of Thunder Bay. It was initially discovered in 2007 and was explored by Kennecott in partnership with Magma Metals and CanStar. And then in 2013, the junior HTX Minerals, with support by IMPALA, acquired the property from Rio Tinto and continued exploration. 2017, North American Palladium, which works the Lac des Îles mine here outside of Thunder Bay, acquired the property and drilled a variety of holes. And this is when I got involved with that. And is this partly cut off? I'm seeing the, can everyone see the whole screen? Yes?
Yes, looks good.
Oh, okay. Sorry. It's kind of bleeding over. Hold on here. Okay. The Sunday Lake intrusion is a funnel-shaped intrusion, like many of these are, like you saw Eagle East. It, however, defines a really nicely well-differentiated sequence that you can break up into 4 major lithostratigraphic units based on its cumulus mineralogy. There's a lower contact zone, mineralized contact zone, which would not be considered a cumulate rock type. This grades then into an olivine cumulate with significant amounts of intercumulus clinopyroxene. Clinopyroxene then becomes cumulus, defining the upper ultramafic series, and then the upper series is plagioclase joining in along with oxide and showing a nice differentiated sequence. There are 2 drill holes, one in what's called the east zone and one progressing over 1.5 kilometers through what's called the Big Red Zone near the root of the intrusion. That I'll show some data from those 2 holes. So these are the modal cumulative modes through the intrusion. Again, olivine dominant in the base. Clinopyroxene is a robust concentration throughout the ultramafic zones, but it's intercumulus in the lower part and cumulus in the upper part. And then plagioclase joins in as well as oxide. This is the shorter hole in the east zone. This is the longer hole in the Big Red Zone. Same phenomenon, and it's clear from the textures. Poikilotic clinopyroxenes in the lower zone then become cumulus and granular in the upper zone. And same thing with plagioclase becoming cumulus when you get into the gabbro zone. So these are the different zones and kind of the cumulus demarcations through the different zones. In terms of just modal rock compositions, these are largely composed of the ultramafic zones are generically peridotites, or more specifically, being completely clinopyroxene dominant, they would classify mostly as wherelites. But you can note in these 2 zones that this highlights the importance of noting texture, and you can't just name rocks by their mode, but you have to be aware of the textures. When cumulus clinopyroxene shows up, it is also still a wherelite, but it's texturally quite distinct. And so in both cases, you can see the open circles indicating intercumulus clinopyroxene, and then the closed red circles indicating cumulus clinopyroxene. But in general, again, they all classify as peridotites or wherelites. just to show you some of the textures. So this is from the basal mineralized zone, really non-cumulate, lots of olivine embedded in Clinopyroxene and plagioclase, significant amount of hornblende as well as biotite. And the sulfide minerals in here, just a typical assemblage of pyrrhotite, chalcopyrite, and some bornite, digenite assemblages on the flanks. We get to the olivine cumulate with intercumulus Clinopyroxene. You can see nice oikocrysts of Clinopyroxene with subhedral olivines embedded in them. And then Clinopyroxene becomes cumulus, they become subprismatic, and an interstitial plagioclase is evident in these sections as well. Then there's, in the transition between the two, you commonly will get kind of hybrid textures where you have pretty massive Clinopyroxenes, but then there'll be inclusions of olivine scattered near the margins of the Clinopyroxene. So this is the transition as Clinopyroxene becomes saturated in the magma column. So I did the petrography through this, and it was evident, you know, again, the textures really helped to define what was going on with the system. But doing petrography, especially in an exploration setting, is rather impractical. And so it's with this kind of a system, though, it was found that using just basic chemistry, you can pretty well define the modal rock types that you see. Plotting this one hole, the very long hole, I'm sorry, the shorter hole, they did a ICP-MS on a meter scale all the way through the intrusion. And then they also recently started doing XRF, handheld XRF analyses. You can see, comparing the two curves for magnesium, they're remarkably similar. So this is a very fast, inexpensive way to do basically chemostratigraphy through the intrusion. And you can see aluminum as well shows a nice trend. Calcium shows a nice trend. If you take this data and you plot it on a magnesium, aluminum, calcium triplot, you can identify where your different rock types should fall, with olivine here, intermediate plagioclase here, and moderately primitive Clinopyroxene here. And you get these clusters of that you can assign rock names to these things based on XRF data. So looking at the total chemostratigraphy of the very long, or actually the shorter hole, looking at the XRF data, it shows, here's a zone that shows obviously chrome spinel, and you can see that petrographically embedded in the olivines are small chrome spinels. The arrival of iron titanium oxide shows up by a spike in titanium, and then magsus, like Esprit just talked about. Apatite is shown by spikes. The arrival of apatite as a cumulus phase, and the gabbro zone is evident here. Increased differentiation, or perhaps trapped liquid component, is evident in some things like zirconium, and the Mg number also shows a nice decline. The mineralization in the intrusion, there's several zones in here that are evident, and these are interpreted to be, this is the basal contact mineralization, really typical style of contamination style mineralization at the base of a gabbro complex. There is evidence perhaps of a mineral recharge event here near the top of the lower ultramafic zone, with a spike in the PGEs and copper. Then there is this unclear zone of, I'm sorry, I jumped up. You can see there's a nice Skaergaard style reef, PGE reef, up in the upper part of the intrusion, just below the arrival of oxide, which is typically found in these tholeiitic systems, and an offset of peaks with the PGEs sitting below the main spike in base metals, in this case, all copper. And then there's this depletion here, which is kind of an odd thing. It looks like it might be related to a very adcumulate, low porosity rock. So all kinds of other interesting things can be gleaned from looking at the chemistry through these, providing proxies for Clinopyroxene and plagioclase, for oxides, incompatible trace elements, showing differentiation trends, looking at ratios as well as signs of contamination. And you can build a rather interesting interpretation from this chemostratigraphy. There seems to be, again, right near the upper lower ultramafic zone contact, some evidence of perhaps another recharge event that leads to some mineralization at that horizon. So the mineralized zones so far recognized are, here is the deep part of the intrusion on this aeromag pattern. There's mineralization been discovered in 3 main areas, and they're continuing to evaluate these. It's open to the west and to the southwest and southeast, and perhaps there might be something leading into a conduit in that particular area. There's a good correlation of sulfur and PGEs continuing through all the mineralized zones. Very classic magmatic sulfide mineralization that Tony would recognize for sure. So just in conclusion, the Sunday Lake intrusion is part of an environment that has demonstrated lots of opportunities to host economic concentrations of PGEs and copper nickel. The Sunday Lake is a well-differentiated intrusion that shows a nice progression of cumulus arrivals of olivine, then clinopyroxene, then plagioclase, disappearance of olivine as oxide arrives, and then later apatite. And it shows a very much like Sanju, a very bottom-up fractional crystallization trend of an initially high magnesium tholate parent. It's variably shows disseminated to semi-massive copper Ni-Cu-PGE enriched sulfide that is largely held at the basal contact zone, but there are several intervals that also host spikes in mineralization. Inflections in mineralogy, texture, and lithogeochem and sulfide mineral concentrations that occur in the ultramafic zone suggest possible minor recharge events that also triggered low-grade sulfide mineralization. And then there's a thick, classic Skaregard type, Sanju type PGE reef that shows stratigraphic offset of PGEs and copper concentrations that straddles the contact between the ultramafic zone and the overlying gabbro zone, triggered probably, as these things seem to be, by the sulfide saturation triggered by fractional crystallization. So that's it. Thank you so much.